Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to be uploading two videos every day, one of the very easy to easy difficulty and one of the average, hard, or very hard. And this one is going to be a hard puzzle, so we'll see how long it takes me to do. And now, on to today's puzzle. Today's puzzle is called Dark Stars by Blobs, and here are the rules. Normal Sudoku rules apply. That is, put the digits 1 through 9 in every row, every column, and every box. Divide the grid into galaxies. Galaxies are orthogonally connected groups of cells that have a 180-degree rotational symmetry about their centers, marked with a small dot. All cells must be part of a galaxy, and no galaxies overlap. So orthogonally connected means that it has to share an edge. So these two are orthogonally connected cells. These two are not. So, for example, let's say that this was a galaxy. So this... Okay, that doesn't work. This would be an example of a galaxy. We could add on, say, two more here, and it would have to have a matching 2 around the galaxy center. And so all cells are part of a galaxy. So that means, so these galaxies are rotationally 180 degrees symmetric, which means that in this galaxy, or let's make it this one, this cell would have to be the same as that cell. And then this cell would have to be the same as that one. Wait. Divide the grid into galaxies orthogonally connected groups of cells that have a 180-degree rotational symmetry. Okay, no, it doesn't say anything about the digits. It's just basically that if those cells are, if this cell is in the galaxy, then this cell's in the galaxy. Same here. If this cell's in the galaxy, this cell's in the galaxy. Yeah, I don't know why I was talking about the digit. Yeah, and then basically that just shows where the galaxies have to be. And all cells, remember, all cells have to be part of the galaxies, and no galaxies overlap. Gray dots mark Renban galaxies. So this is a gray dot here, this is a gray dot, this is a gray dot. Those with 2 or more cells whose digits form an unbroken consecutive sequence in any order. So that means in the galaxies, they have to have digits that form a consecutive sequence. So from like, if there's a 6-cell galaxy, it would have to be, say it was a 6-cell galaxy, say it was like this. It would have to have the numbers like 3 through 8, or 2 through 7, or 1 through 6, or 4 through 9, basically. Those are Renban galaxies. White dots mark galaxies whose digits do not form a sequence. So these digits do not form a sequence. Digits may not repeat within a galaxy, so galaxies can only be 9 large. 6 single-cell galaxies, dark stars, are not marked. Okay, so there are 6 galaxies which are not marked, and they are single-cell. Wait, so can the gray dots be single cells? I don't know. I'm not sure. I don't think so, right? Because it's saying that in the 6 single cell galaxies, dark stars. Oh, maybe it's possible. I don't know. We'll have to take a look at there. Their locations must be deduced by the solver. All cells, max 8, around a dark star belong to regular galaxies. So that means you cannot have a dark star next to a dark star. So you can't have a dark star next to a dark star. They all have to be part of another galaxy, a normal galaxy or a regular galaxy. Digits do not repeat amongst the dark stars. So you have six unique digits in the single cell galaxies, in those single cell galaxies. I'm not sure because it does state in the Renbei galaxies those with two or more cells. So does that mean that the Renbei galaxies can be one cell? I'm not sure. As per galactic map standards, all galaxies with at least two cells indicate their smallest digit with a diamond icon. So if it's a diamond icon, that means it's in a regular galaxy. It's in a galaxy with at least two cells. And it's the smallest digit in that galaxy. All galaxies with at least six cells indicate their largest digit with a circle icon. Okay. So that means the circle is always in a galaxy with at least six digits. Six digits. And it's the largest one. And remember, digits cannot repeat within a galaxy. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So I don't know whether the dotted galaxies have to be two or greater. One thing we do know is this: like if they're on an edge or a corner, if they're on a corner, there's at least four. If they're on an edge, there's at least two. So we know again, like for example, these two are in the same one. These four are in the same galaxy. These two are in the same galaxy. The circle has at least six. And the diamonds have at least two. So this one's always two. This one's at least two. I forgot that I didn't say. So this is at least two, this is at least two, and those are the small ones. This is at least two. This is at least two. This is at least six because it has a circle. We don't know what directions it goes, though. This is at least two. This is at least two. This is at least two. This is at... Anything that has that is at least two. So here we've got at least three different galaxies. It cannot be the orange. It could be the purple. It could be the green. It could be the blue. Here's at least three, right? This is at least six. And it cannot be the red one. So we know, yeah, because if it were the red one, it would have to go here. So this is a let's do edges. This has to be a boundary. We don't know what it is though. Same here. This has to be 6, so that's at least a boundary. What other boundaries do we have? This has to be a boundary because... Wait, this could be the same one. Interesting. Okay, so this has to be a boundary, definitely, because we know this can't be... These both cannot be the smallest, because they're different digits. So this one can't be either. So this could be essentially one that's 2 in length. We also know that the gray ones are Renban ones. This is 4. This is at least 6. This is a Renban, and it's the smallest. So this is at least 3. Um, hmm. So this is at least 3. Yeah, I don't. So this could be that way. That would be 6. Remember, there are dark star ones. So if this is 6, if it goes this way, then this has to be 3 and then a dot. So that's a dark star. And there are 6 dark star galaxies. Again, I'm not sure if that means that the Renban or the non-Renban galaxies, regular galaxies, can also be single digits. So for the galaxies, if it's in a different box, in a different row, and a different column, it could actually be part of the same. Okay, so this cannot be part. Okay, so we know the length of this. This cannot go here because this is a separate galaxy. So we know this is a separate galaxy by itself. So then this has a border too. This one we don't know. Right? It cannot go up and down. It can't go left and right. So this one's just these two. And it's a Renban. So this is the smaller of them. Which doesn't give us much. It's 1 through 8, and this is the bigger one of them. It's 2 through 9. Okay, this is at least 6. This has to be 7. At least. So this is at least 7. Okay, if it contained this one, so say this blue contained this one, it would have to go here, but then it gets blocked by these two. It can't go that way. And it can't go this way because it's part of a different galaxy. So it cannot go up. So we know this is a boundary. So this is a boundary. And because that's a boundary, we know exactly where that goes. That goes here, right? And it cannot go to green because that's a separate galaxy. So, and it cannot go down because that's a separate galaxy. So it has to go this way. So we know these two have to be part of the blue galaxy. And it cannot go down either. So these are locked. Now it has to go up or down or both. That's possible if these dots can be only 1. We do know it has to go one of the 2 ways, though. So it cannot go this way, which means this one can't be. Maybe I should make these red. I'm going to make these red so that it's clearer. Green's a little hard to see. And red's not that great either, but red's slightly better. So this can't be, this can't be, this can't be. Okay, that means also, okay, so this can't be then, and this can't be. Oh, interesting. So this cannot be from purple. Technically, you could go up and it could be the same number, right? So it could be like that. That could be the case. It could also be the case. What it's telling me, though, I think is most likely it's not this one. So it would probably be this one, but we don't know. Okay. Also, this one can't be, right? We need to, yeah, lock in all those. These can't be. This one can't be, so now this one can't be. This one can't be. Um, so either this is 1 or this is 3, right? If this is 1, say this was 1, this could be a dark star, but the problem is, I guess that could be a dark star too. Okay, if this is 1, it could be something like that, right? Oh, wait. Digits may not repeat within a galaxy. Okay, so this cannot go this way. Okay, digits cannot repeat within a galaxy. So it cannot go that way because then these two would be the same number. Right, so okay, yeah, you cannot. Yes, so then this one can't go that way. This one, that eliminates that. Right, digits cannot repeat in a galaxy. I didn't process that correctly. So then we know this galaxy has to have at least 6, so it has to go down, and then it has to go up. So this is the full galaxy. And this is the full galaxy. So this is a full galaxy. We know that 2 dark stars cannot be next to each other. And this would have to be 2 dark stars because there's no other galaxy center with it. So these two cannot be dark star galaxies next to each other. So this has to be 3 then, for that to be the case. So we know this is 3. We know this is a dark star galaxy. So this is a galaxy, this is a galaxy, this is a dark star. This cannot be part of this. I guess it could be part of that. This could be 4, though. What other galaxy can it be a part of, though? It can't be part of this. It can't be part of any other one that we see. So it has to be part of green. This has to be part of green, which means that's green. It cannot go up. So then we know this is a 4-cell galaxy. This is looking like a dark star, right? So this one's looking like a dark star because where can this go? This can only go here, right? And it has to be... Ooh. Wait. No. This has to go here. It cannot go part... Yeah. This cannot be part of this galaxy because where does this go then? This can't be part of any galaxy except for this one. So it has to go here, which means it cannot... So this one has to go up to here. So this is at least... This is 7 too, at least. It could be more. Oh, it can't be 9. No, this has to be 7 exactly because it's not Renban. So the Renban would force that to be 9. Or, sorry, a 9-cell galaxy would have to be a Renban galaxy. It just has to. So this has to be 7 and only 7, right? So then, where are the limits here? It cannot go this way. It cannot go this way. So it could go out here. It could go to one of these two cells, but that means it has to go down. So it has to go down here. This seems fine. It could expand here instead, or it could go here. This one, what galaxy can it be part of? It can only be part of the purple galaxy, which means it's there too. Which means we know this is blocked, so this is contiguous. It cannot be part of this, so this square is also a dark star. So we have two dark stars now. We don't know about that one. This could be blue. What galaxy can this be a part of? It can't be part of this one. Can't be part of this one. Can't be part of this one, so this has to be a dark star. And there's 3 more only. Wow. Okay, so this one could be pink or blue. This could be pink or blue. It has to be pink or blue, essentially. This one's pink or blue. We don't know which. This cannot be pink. This could be part of this one. I think this one has to be part of this, right? What other galaxy center can it be around? And it's 2 or more. So this has to be part of this one. So this is red. So this one would have to be red. Right, so that's done. We're not done. So this cannot be pink. No, one of these two is pink. Okay, there's too many. Okay, so if this is a dark star. Okay, so this cannot be more than 7. So it can only take. So we have 3 already. If we added 3, this would have to be 3 also. So that does not work. This could add 1. It could add 2. But it cannot add 3. So at best, 2 out of these 3 are red. At most. So this cannot be. So one of these then would have to be a dark star. I guess it could be like that. So this could be a dark star. And then that could be a dark star. Actually, I don't think that works. Okay, so this is something else. This could be blue. Okay, so this one has to be part of a galaxy also. So let's make that purple. So it has to be part of this one. Because, I mean, it can't be part of that one because then this would have to be a Renban one. So it has to be part of that. And I think that's it, right? This is kind of limited. And therefore this, it doesn't have to be a dark star. And in fact, we only have 3 more dark stars available. So we just know that this has to go here and here. Okay. Where this one can be part of blue. This can't be part of blue. It can't be part of red. It can't be part of green. This has to be a dark star. Right? Yeah, it can't be part of blue. Can't be part of green. Can't be part of blue because of this. Can't be part of red because this is too far. And so it gets blocked. So this has to be a dark star. Which means this has to be part of something. And it cannot be part of red, and it cannot be part of blue. So this has to be part of the green galaxy here, which means this is also part of the green galaxy. So this is either part of, okay, cannot be part of that. This has to also be green then, right? Where can this be a part of a 6-cell galaxy? It can't be part of a 6-cell here because this one's something different. Right, because if if this is part of this galaxy, it has to enter through here. And that would be another one part of the galaxy, which is not possible. So yeah, this cannot be part of this galaxy because that's not. Therefore, this is part of the green galaxy. And I think that's it then, right? So this encloses a 6 galaxy. Um, Therefore, this is either red or blue. We don't know which. This is either red or blue. This cannot be red or blue. It could be blue. It could be part of a dark star. Uh, hmm. Okay, say this was only 2 in length, 2 in size. If this was only 2 in size, this would have to be blue. That would have to be blue, but then neither of these can be blue, and then you would have 2 dark stars next to each other. Therefore, this cannot be blue. This has to be the red. This has to be red. And because of that, this cannot be blue. So it has to be purple, which makes that purple. So therefore, this has to be the blue, and this has to be blue. So these are all galaxies. This is galaxy. Um, that doesn't tell us very much, does it? So this is part of a 6. This is part of a 6 or more. This one. So this, I'm gonna make that, I don't know, pink. Okay, this is blocked here because of this one. If, okay, what galaxy does this belong to? It cannot belong to the pink. It cannot belong to any of these anymore. It can't belong to this red because it doesn't have a corresponding cell. So think this has to be a dark galaxy. It can't go to here because, again, it can't belong to a cell. Yeah. So this has to be a dark galaxy. Which means none of the ones around it is a dark galaxy. So this has to be part of the pink one. So this has to be pink. And we only have one more dark galaxy possible. So if this is neither, this can't be part of a galaxy, and you would have 2 dark stars. So that's not possible. So these are both part of a galaxy. This galaxy. Okay, this one cannot be. Okay. So we know, oh, we don't know. If this is not, if this is a single if this is a 1-cell galaxy, both of these would have to be dark stars, which is not possible because they don't belong to any galaxy. So this cannot be 1. This has to be at least 3. So this has to go this way. It could potentially be that that's a dark star. We don't know. Huh. So this could be a dark star. Okay, so if this is 3, this is a dark star, but this could be yellow, 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 yellow. Okay, and in fact, it would have to be yellow, 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 right? Hmm. Okay. Where does this galaxy go? So say this is a 3-star galaxy. This can't be part of a yellow, so that would be a dark star. This can't be part of anything else. It can't be part of purple, can't be part of red. Everything else is set, so that would not work. So you would have 2 dark stars. This cannot be part of anything except for yellow, but the yellow doesn't have a corresponding cell. So this has to be at least 5. So this is only 5, right? Because this is blocked here. So this is blocked here. So this is 5. This has to be a dark star. This cell has to be a dark star because there's no corresponding one for the purple. And it can't go up for the red. So it can't be in the red. So this has to be the only dark star. So since this is the only last remaining dark star, that means this is green, which means this has to be connected to here. So it's that way. This has to be part of yellow, so it has to be connected here. And this has to be part of purple, which means it's connected here. Okay, so we've got all the galaxies now. This is yellow. This is green. Okay. Okay, so what do we have? This is not a Renban, so it cannot be 7, 8, or 9. It has to be 8 or 9. Because if it's 7, that means it's the largest in a 7-cell galaxy. But if it were a 7-cell Renban galaxy, it would have to be 1 through 7. Sorry, if it has to be 1 through 7, then it would have to be a Renban galaxy, and this is not one. So this is 8 or 9. This is 8 or 9 too. So there cannot be 8 or 9 anywhere else here. So this is 8 or 9, which means this is 1, 2, 3, 4, 5, 6, 7. This is the smallest one. I guess, no, it cannot be 7. If this can't be 7, because if that's 7, the smallest one would be 7. Yeah. This is a 4 square 4-cell galaxy. So it would have to be at 6 at least, but the problem with 6 is it has to have 7, 8, and 9, and that's 8 and 9. So this cannot be 6 either. So it could be 5. 5 is valid. This is also a Renban, but it's a 6-cell Renban galaxy. So that means it could be 6, 7, 8, 9 as the largest one, or 1, 2, 3, 4 as the smallest. Do we have, okay, this has to be a 9 because it's an 8-cell Renban, but it's not, sorry, it's 8-cell galaxy, but it's not a Renban, which means it's not continuous. So if it were 8, that would mean it would be continuous from 1 through 8. So this has to be a 9, and this has to be a 1 because, again, if it were 2, that would be continuous from 2 through 9. And that's not possible because it's not a Renban galaxy. It's just a normal galaxy. Okay, this is Renban. Okay, so this is 8 through 9. This has to be 1 or 2. It cannot be 3 because if it were, it's not a Renban galaxy. If it were 3, it would be 3, 4, 5, 6, 7, 8, 9. So this is 1 or 2. This is 1 or 2. This is the smallest. This is Renban. So this has to have a 5 in it. We don't know what the other numbers are, though. This is also Renban. Interesting. This is not. So this is 1 or 2. We have 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. This could be 2. Oh, wait, this is small. 4, 5, 6. So it cannot be 7. This can't be 1 because it's part of that. So this can't be 1. Okay, so this is 2, 3, 4, 5, 6, 7. This is 3, 4, 5, 6, 7, 8. This is non-Renban. This is Renban. This is Renban. The dark stars. Does that tell us anything? Not really. This can't be 1 or 9. So this is 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Because this is Renban and it's 6. So it's either 1 through 6, 2 through 7, 3 through 8, and 4 through 9. This could be 9. That could be 9. Okay, so this can't, this is 2, 3, 4, 5, 6, 7, 8. This is also 2, 3, 4, 5, 6, 7, 8. This is also 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. Okay, let me just double check the rules to make sure we're not missing anything. Okay, orthogonal connected groups and blah blah blah. Gray dots from Renban. Those are 2 which digits form an unbroken consecutive sequence in any order. White dots mark galaxies that do not form a sequence. Digits may not repeat within galaxies. Single cell galaxies are not marked. Location must be deduced. We have that already. All cells around a dark star belong to regular galaxies, which is this case. Digits do not repeat amongst the dark stars. All galaxies with 2 cells have diamonds. Okay, yeah. So that's everything. This is 5, 6, 7, 8. No, this is lowest. So this is 1, 2, 3, 4, 5. So it can't be 1. Oh. So this is 3, 4, 5, 6, 7, 8, 9. This is 3, 4, 5, 6, 7, 8, 9. So this has to have 5 and 6. Because it cannot be 1 as the lowest here. So this is 1, 2, 3, 4, 7, 8, 9. This is 1, 2, 3, 4, 7, 8, 9. Interesting. This is the lowest also. Cannot be 7, 8. So this is 1, 2, 3, 4. It can't be 5 or 6. So this is 1, 2, 3, 4. So it's 1 through 4 or 4 through 7. Right? So this would have to be either 5, 6, or it's 1 through 4. Because this is Renban. So this is the lowest. Okay, so this is the lowest. So it cannot be 1. This can't be 1. So it could be 1 with 2 through 4, or it's 4 with 7. Wait, this cannot be 4 and 7. Say this was 4 and 7. That eliminates both possibilities around here, which is a Renban. So this cannot be 4 and 7. This is 1, 2, 3, 4. It could be up to 6. It could be 3, 4, 5, 6. And this would be 5, 6, 7, 8, 9. And this would be 1, 2 here. Wait, but if this is 1, 2, it cannot be the lowest, so this can't be 1. So therefore, this is 1. This is the only place, oops. This is the only place for 1. Therefore, this is 2, 3, 4. It cannot be 5 or 6. This is not Renban, but this has to be 1 through 8. This is 2, 3, 4, 5, 6, 7, 8, 9. So this is cannot be 1, 2, 3, 4. So this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. This is the lowest 1. So this is 1 through 7, because this is 1 through 5. Okay, yeah, we should do the lowest one. This is 1 through 6. This is 1 through 6. This is 1 through 5. These could be a lot. This is not Renban. So this is Renban, that's done. 2, it cannot be 2, because if it were 2, this would have to be 2, 3, 4, 5, and that would eliminate that. So this cannot be 2. So this is at least 3. This is not Renban, so that doesn't limit anything. Where are the 1 possibilities? Maybe I should be looking at, I should have been looking at the 1 possibilities. So these 2 are 1s. These 2 are 1 possibilities. These 2 are 1 possibilities. Dark stars could contain a 1. So this is a 1. This cannot be 1. So this can't be 6, which means 2 cannot be here either. This could be 1, but it can't be because of Renban. This can't be 1. Okay, so this has to be 1. This is the only possibility for 1. Because none of these can be 1 anymore. That can't be 1 because it sees that and that. And these 2 are not the smallest one, so they can't be 1. So this is 1. This can't be 1. So the 1 is one of those 2. This can't be 1 anymore. So this can't be 2. This can't be 1. This can't be 1. This can't be 1. This can't be 1. So this is 1. So since this is 1, that can't be 1 anymore. This can't be 1. None of these can be 1. So the 1 has to be here, which means this cannot be 1, which means this is 1. So this is Renban, so that's 2. So this can't be 1 or 2. So this is 3, 4, 5, 6. And this is 4, 5, 6, 7, 8, 9. And the 9 cannot be here. So this can't be 1. This can't be 1. This can't be 1. So this has to be the 1. Okay, where are the 1s? So 1 could still be one of those. 1 cannot be this anymore. This can't be 1. I can't type. What the? What's going on? This can't be 1. So this, none of these can be 2. So this has to be the 1. Because it's the smallest digit. So this is 1, this is 1, this is 1, this is 1. This can't be 1. Therefore, this has to be 1. This can't be 1. Oh, wait, no. This can't be 1. So this has to be the 1 also. There's no other place for it. So that means one of these, this can't be it. So this is 1. So that's a dark star with 1. Now we can similarly look for 2s, right? Where are the 2 possibilities? Well, this could be 2 also. So 2 cannot be here. Okay, this can't be 2. This can't be 1, so this can't be 2. 2 could be here, 2 could be here, 2 could be here. So 2 could be any of these two. So, okay, that's not helpful. That's too many things going on. This is 3, 4, or 5. Okay. If it's 3, it would have to be 3 through 7, so this cannot be 7. This is consecutive. I guess it could still be 2, 3. Yeah, that seems fine. Oh, this cannot be 5. If this is 5, this would have to be a renban because it's 5 length. So this is 2, 3, 4. This can't be 6 because this would have to form a renban also. And it's the smallest one. This is a renban. So it's either 3 through 6, 4 through 7, 5 through 8, or 6 through 9. So there's a 6 always there, but that doesn't really tell us much. Okay, let's remove these circles because they're getting confusing. Okay. 2. Where can 2 be? We only have one. So this can't be 2. This can't be 2. This can't be 2. This can't be 2. So 2 is either here or it's here. We know the 2's here in this one. 2 could be either this, this, or this. Right, so the 2's could go there. This cannot be 2. Oh, one of these 2 is 2. This can't be 2 because this would have to, this is the lowest and it can't be 1. So therefore the 2 can only be here anymore. So this is not 2. So 2 is one of these 2. 2, oh, 2 cannot be here either because of this. So this is 2. Therefore this has to be 2. Since that's 2, this can't be 2, so this can't be 3 even. So none of these can be 2. This can't be 2. Therefore, this has to have a 2, which means this cannot be 2. So this is 2, which means this can't be 2, which means this can't be 3. This can't be 2. This can't be 2. Aha. So the 2 has to be here, which means that this can't be 2. This can't be 2. This can't be 2. So the 2 has to be here, which means this can't be 2. So 2 has to be one of those 2, which is possible. So this is 2, which means this cannot be 2, which means this has to be 2. And there's no 3 or 4 here. So this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. This is 2, and it's the lowest part. So this is 2. This can't be 2, so this can't be 2 either. So this has to be the 2. So this is 2. We have a 2 here. This could be 2. This could be 2. So the 2 has to, oops. The 2 has to be one of those 2. The 2 has to be one of those 2. Oh. So then the 2 has to be one of those 2. So the 2 is one of those 2, the 2 is one of those 2, and the 2 is one of those 2. This is continuous. Okay. Where are 3 and 4? One of these 2 is 2. This is not Renban, so it's not continuous. This is Renban. This is also Renban. Oh, this cannot be... Right, there is no 9 here. Okay. There's no 9 here because this is at most 5, 6, 7, 8. And this can't be 9. So this has to be the 9. So this is 9. This is 8. So this can't be 8. This can't be 9. This can't be 9. So either that's 9 or one of these is 9. This can't be 8. This can't be 8. So this is 2 or 8. This is 2 or 8. So this can't be 8. This is 3, 4, 5, 6, 7. This could be 8. Oh, no 3. This can't be 3. It could be 5, 6, 7. That's 8. This is 2 or 8. This is 2 or 8. This has a 9, so this can't be 9. So this can't be 9. This can't be 9. Therefore, one of those two is 9. So this can't be 9. So we know one of those two is 9. Okay, that doesn't really help very much. This is 2, 8 or 2, 8. This is the lowest. So this is 3, 4, 3, 4, 5, 6. It cannot be 7. And obviously it can't be 9. So all the ones are taken care of. 1, 2, 3, 4, 5, 6, 7, 8, 9. Twos, we know one of them's here. One of them's here. One of them's here. One of them's here. And then one of them's here. Three. Three could be here, here, or here. Okay, what other Renbands do we have? So this is 3 through 7, 4 through 8, or 5 through 9. What other Renbands are there? That one. This is not a Renban. This is a Renban. This is not. This is. Just by being 8, yeah, it's fine. So it could be 5, 6, 7, 8. This is also a Renban. So it's either 2 through 7, 3 through 8, or 4 through 9. So 4 through 7 is there. This cannot be 1. It cannot be 2. So this is 3, 4, 5, 6, 7, 8, 9. Oh, where's the 9? 9 can't be... Okay, so 9 cannot be here. 9 can't be anywhere here. So this has to be the only place for 9. So this is 9, which means this can't be 9, which means this is 9. So this cannot be 9 anymore, so this can't be 4. So we have a 3 through 7 then that are guaranteed, and the question is whether we have a 2 or not, right? So this is 3, 4, 5, 6, 7, 8. No 9. This could 3, 4, 5, 6, 7, 8 also. Um, so this can't be 9, so therefore this is 9, which eliminates 9 from these. This can't be 9, so this has to be 9. So this can't be 9, this can't be 9. So one of these two is a 9. One of those two is a 9. And one of these two is a 9. So we have one of these two, one of these two, one of these two. Okay. Any other restrictions? I don't think so. This is 3, 4, 5, 6, 7. This is 3, 4, 5, 6, 7. Okay. What other 9s could be? This is 3, 4, 5, 6, 7. Can't be 3. We know the 2's here. The 8 also has to be here now, too. So this could be 8, and that would be 5. So if this is 8, so either this is 2 and 8, or this is 8, and this is 5, 6, 7, right? And if this is 5, 6, 7, this has to be 8 and 3. So this can't be 3. So this is 3 through 6. Okay, yeah. This is 3 through 6, 4 through 7, or 5 through 8. So 5 and 6 cannot be in any of this box. In addition, either this is 2 and 8, or this is 8, which forces this to be 5, 6, 7, and this 6, 7 forces this to be 8 and 3. So this can't be 3. So this would have to be 2, 3. So this is either 2, 3 or 2, 8. We don't know which. This can't be 6 anymore. If this was 6, this would be 6, 7, 8, 9. And we know that can't be the case. So it's 3, 4, 5. So this is 2. Don't know what those are. Interesting. So this has to be one of these two. Oh. If this was 8, where can the 8 be in this middle box? It can't be anywhere. Yeah. It cannot be. If this was 8, that eliminates 8 from here. This can't be 8 because of it's a smaller one of a Renban, and that can't be 9. Can't be here because of the galaxy. So this can never be 8. So this has to be 2. This has to be 8, which eliminates 8 from the dark stars. So this cannot be 2 anymore, which forces this to be 2, this to be 3. This can't be 2. This has to be 2 now, so that's 7. This can't be 7, so this has to be not 8, because it can't be, it's a Renban. Therefore, this has to be the 8, and this has to be 2. So this can't be 7, this can't be 7, this can't be 7. No 7 or 8, no 7 or 8, no 7. So we have 3, 4, 5, 6. So this becomes, this cannot have 5 or 6. So this is 3, 4 with 7 or 8. This can't be 2 anymore, so this has to be 2. This can't be 3, so we have 4 or 5, which means 8 cannot be here anymore. So, and 3 does have to be here, so this can't be 3. No 8. This can't be 4. So this is 5 or 6, 3, 4, 5, 6, 7. No 3. This is 2 and 8. So this cannot, okay, so this cannot be 4. If this was 4, where does the 3 go? This would have to be 3, but it's a ren band, so that can't be. So this has to be 3, which means this is 4, 5, 6, which means this can't be 4. So this is 3, 7, 8, which means this is 4, this is 3. This cannot be 8, so this is 5 or 6. This cannot be 5 or 6. This is 8 and 9. So this can't be 3. This is 4, 5, 6, and this has to be 7. So this is 4 because it's the smallest. This has to be 4. This can't be 4, no 4, no 4, no 7, no 4, no 3, no 3, which means this can't be 4. This can't be 7. Where are the 3's here? The 3 cannot be anywhere but here, so this is 3. That forces this to be 3, so this can't be 3, so that's 3. So this is 4 or 9, which is fine. We have 3, 3, so this has to be the 3, which means this can't be 3, which means the 3 has to be here, so that can't be 3. 3 cannot be here anymore, 3 can't be here, so this has to be the 3, which means that's 3. This can't be 3, that can't be 3. This can't be 8 anymore, so this is 7. This is 8. This can't be 7 or 8, so it's 4, 5, or 6. So this has 4, 5, 6, 7, and I guess 8 has to be here. This can't be 4, this can't be 7. No 7 here. So this has to have a 7, because it's either 4, 5, 6, 7 or 5, 6, 7, 8, so that's 7. This can't be 7. This can't be 7. This can't be 7, so none of these can be 7, so this has to be the 7, which means that's the 7. So no 7, this is 5, 6. This can't be 7, that can't be 7, no 8, no 7. This is 4, 5, 6, 7, 8, 9, no 7 or 9. This can't be 3. We have 4, 5, 6, 4, 5, 6, 4, 5, 6. 5, 6, 7, 4, 5, 6, 4, 5. So the 6 has to be here, which means this can't be 6, which means this can't be 6. This is 5, this is 6, this is 4. 5, 6, this is 4, 5. This is 6, 8, so this has to be 5. 6, 5. This is 4, this is 6, this is 8, 6, 5, 9. So that forces that to be 4, 5, 6, 5. This is 7, this is 8, so this is 6. This has to be 4, and this is 9. This is 8. 7, 6, 8, 9. This is 7, 4, 5, 6. And that's the puzzle. Oh, that was a very clever puzzle. I like that. Especially with the low galaxy marks and the high galaxy marks. It forces very specific restrictions. Anyways, I hope you enjoyed that solve, and I'll see you next time. Take care.